This presentation will consider the following question. Lean Six Sigma and Design for Six Sigma can both be beneficial to organisations. Consider the relationship between the two approaches and recommend how an organisation might select the appropriate approach or combine the two to deliver optimal business benefit. Six Sigma is a set of statistical methods used to improve a business's products, services or processes through reducing variation, i.e. how many defects are expected in the products, services or processes. How far a process is deviating from perfection is defined by the customer's ideal and is measured using defects per million opportunities. Achieving Six Sigma performance indicates that the products, services or processes are within 3 standard deviations from the mean, which is the customer's ideal. This means achieving 99.74% customer satisfaction or product pass rate and 2600 defects per million opportunities. Achieving 12 Sigma performance indicates achieving 99.9996% satisfaction and 3.4 defects per million opportunities. Lean Six Sigma integrates the lean thinking, or eliminating waste, into Six Sigma methodology. So, what is lean? Lean is, according to the Association of Manufacturing Excellence, a customer-based production practice or pull system that improves the efficiency of a company's production processes by eliminating sources of waste. Sources of waste are identified by focusing on the creation of value for the end customer at each stage of the production process. Then, considering the expenditure of resources for anything other than customer value to be non-value adding, hence wasteful, and thus target for elimination. This helps to maintain or even improve quality while cutting cost. Lean identifies 3 waste aspects in organisations: Muda, which is wastes, Muri, which is overburden, and Mura, which is variability. 8 categories of waste fall under Muda: defects, overproduction, waiting, non-utilised talent, transportation, inventory, motion, and extra processing. Lean focuses on flexibility, flow, and speed. Design for Six Sigma is an approach to the new product introduction process, of which an example is shown. It makes use of statistical analysis tools to simulate, predict, and identify early the performance of a new product, service, or process. Design for Six Sigma differs from traditional Six Sigma and Lean Six Sigma mainly because it does not require an existing functional process to be in place. Rather, Design for Six Sigma focuses on designing and creating better processes over improving existing processes. It is important to note that since Design for Six Sigma focuses on designing new processes or better versions of existing processes following scientific breakthroughs, it does require knowledge of the existing processes. The DMAIC cycle consists of 5 sections: define, measure, analyse, improve, and control. The define phase is used to identify what the problem is within the current process, where the opportunity for improvement is, what the project goals are, and what the internal and external customer requirements are. The measure phase consists of collecting data on the current system to quantify process performance. This is then used in the analyse section to determine the root causes of variation and poor performance. These root causes can be narrowed down or prioritised to establish improvements which address and eliminate these root causes. Finally, the control section ensures that the improvements made to the process are maintained and quantified. To assist the DMAIC cycle, an array of tools can be used, the first of which is an Ishikawa or cause and effect diagram, which identifies any causes for a specific event, such as a defect. A process flowchart is a map of a process that a team is working on. It is meant to show what is happening rather than what is meant to happen during a process. A Pareto chart is used to graphically summarise and display the relative importance of the differences between different groups of data. Histograms are great at showing how capable a process is. Adding specification limits on top of a histogram graphically shows how many objects are within the limit, revealing its capability. A control chart is a graph used to study how a process changes over time. The DMADVA cycle consists of 5 stages: define, measure, analysis, design, and verify. It is important to note that the DMADVA cycle is in more ways than not similar to the DMAIC cycle, as it requires the same information on the existing process to be implemented. The main difference is that it requires a different toolset and different methodologies to design a Six Sigma performance level process. Define. Define the goals of the project, the purpose of the process, service or project, and set realistic goals. Measure. Measure factors critical to quality. Identify the critical design parameters. Design scorecards that will evaluate the design components more important to the quality. Assess the production process capability and product capability. Analyze. Develop design alternatives. Identify the optimal combination of requirements to achieve value within constraints. Develop conceptual designs. Evaluating, then selecting the best components. Design. Design detailed and high-level design for the selected alternative. Verify. Is it acceptable to all stakeholders? Expectations will be confirmed. Deployment will be expanded. Lessons learned will be documented. To achieve this, DMADVA has a number of tools available for use. Much of these are the same for standard Six Sigma, such as QFD, design of experiments, and process capability analysis. In addition to these, there are also the design-specific tools employed, such as FMECA, Pew Matrix, QFD, and Voice of the Customer. A failure mode, effects, and criticality analysis is used to identify potential failure points within a process or product. It ranks potential failures based on the probabilities and severities to allow for comparison between potential problems. The Pew Matrix helps determine which items or potential solutions are more important or better than others. It is employed after capturing voice of the customer. Which is best for your organisation? If your organisation is new to the Six Sigma methodology, the answer is almost always Lean Six Sigma. This will focus upon improving your current processes and on giving your personnel the knowledge to progress into design for Six Sigma, which is a fundamental requirement.
Luigi, why are you so upset with our pizzeria? You are an idiot, Mario. It is so inefficient. We have too much variation, and look at all of our inventory.
Luigi is right. We have enough pizza here to last us a month, and most of them have pineapple on them. Gross.
I can't watch you run this pizza empire into the ground. We need to start over and design our pizzeria from the ground up. This pizzeria has been successful for the past 15 years. We don't need to change a thing. If you want something new, then leave. I'm starting my rival pizzeria and designing it from the beginning. Wolio told me about applying Lean Six Sigma and how it could save me thousands. Ciao. First, I need to define what to do. I'll use a SIPOC to see what to do. I'll focus on improving the cooking and prep. What is a pizzeria without good pizza? Oh no! To improve the process, I need the data of the current process.
Need some data? I've been spying on Mario to ruin him. You want it? You can buy it off me.
I guess I have no choice. Ciao, Bella. Looking at this graph, it is obvious that pineapple is the most popular topping. Therefore, to simplify the supply chain and reduce variation, I will be making a pineapple pizzeria. This is a good starting point. I need to design my pizzeria with design for Six Sigma in mind, allowing us to have a performance of 99.74% customer satisfaction. Let's start over with a brand new building and layout. Let's take a better look at what I have implemented. All of these processes reduce the variation in my pizzas and reduce the waste of my operation. The production process is made to order. Therefore, once an order is placed, we start the production of the pizza. This ensures that we do not have any overproduction. The dough for each pizza is exactly weighed and then placed on the production line. The dough is then pressed by a pizza press and given an exact 12-inch diameter. The weighed sauce is added to the pizza. The toppings are then added to the pizza and it is finally moved to the oven. Each pizza is baked at the fixed time of 15 minutes at 200 degrees. The cooked pizza is then taken directly to delivery and the order is completed. When the new order is placed, the process repeats. The ingredient safety stock are also replenished to the normal level. At each process stage, I have installed SPC cameras which monitor the variation in each pizza. This level of variation control ensures that we give the customer exactly what they want every single time they come through the door. With this, I am trying to reach Six Sigma. With our reduced variation, the customer will know exactly what they are getting, allowing us to have a performance of 99.99999 of customer satisfaction. Although designing for Lean Six Sigma has cost my pizzeria a significant investment, the savings and the customer satisfaction will make it worthwhile.
How did Luigi's Pizzeria become so successful? Maybe he was right about applying Lean Six Sigma. I remember seeing a book on Luigi's desk, The Machine That Changed the World. I will give this a read. Let's take a look at what I need to change in my pizzeria to achieve Six Sigma. Looks like I have a lot of things to improve in my pizzeria. I am going to have to get help from somewhere. If only I knew a purple belt Six Sigma guru. Don't worry, Mario. I can't let that idiot Luigi win. Let's have a look at your current processes and how we can apply Lean Six Sigma to improve them. Let's do some analysis as to why the customers aren't happy. The Pareto analysis shows that the main cause is burnt and overcooked pizzas. Therefore, it is time for a new oven or cooking process. At the moment, unskilled Toad over there has no way of knowing when to take the pizza out. Help him out by fixing the cooking time and adding a timer. It looks like you have a problem with high inventory of ingredients. Your fridge is overflowing with prepared dough. If you are set on making to stock, then statistical forecasting should be used to determine how much dough will be used. This will reduce overproduction. The next process that we can improve is the variation of your pizzas. Currently, each customer picks the topping they want for their pizza. This results in a large variation in pizzas produced, which will complicate the ordering of ingredients. Create a set menu of pizzas to simplify the supply chain. Allowing the company to run for 14 weeks has given us enough data to compare the statistical analysis of the variation in number of burnt pizzas per week. The statistical control graph indicates the number of pizzas burnt throughout the 19-week period. Here, it shows that the mean value is 8 burnt pizzas. The second graph shows the results of the number of burnt pizzas after the changes have been implemented for the 19-week period, giving a mean of 3 burnt pizzas. Result! After implementing the design for Six Sigma methodology and the demand cycle, I was able to control the weight, diameter, temperature, and cooking time of the pizza. As a result, the number of customers at my pizzeria per week is 23% more than Mario's, and customer surveys tell me that customer satisfaction has increased to 95%. I've also saved £5,000 per month on expenses. This is perfect! So after 19 weeks, we can see that by implementing the Lean Six Sigma methodology using the Dominic cycle, we have identified the key areas of improvement to the inventory. As a result, we have been able to reduce the number of defects in the pizzas to 3 per week. The rate of waste has reduced by 40%, and our surveys show that customer satisfaction has increased 20%. This is almost as good as Luigi's!